Hi friends, today I am giving a lecture on a recursive algorithm for backtracking general method. Okay, so backtracking is one of the algorithm design technique in design and analysis of algorithms. There are many applications of backtracking. So mainly first application is n-queens problem. Second application is sum of subsets problem. Third one is graph coloring problem. Fourth one is Hamiltonian cycles problem. Okay, so these are the four applications of backtracking method. In many applications of the backtracking method, okay, the desired solution can be expressed as n tuple. Okay, n tuple. So these n tuples can be expressed as a1 comma a2 comma a3 comma up to an, where each ai can be chosen from the finite set S suffix I. Okay, so this is the finite set. From this finite set, each ai can be chosen a value from the finite set S suffix I. Okay, so each ai can be called as one vector. Okay, this vector satisfies the bounding function or criteria function. So that criteria function can be expressed as a1 comma a2 comma a3 comma up to an. Okay, each vector a suffix I can maximizes or minimizes or satisfies the criteria function p suffix I of a1 comma a2 comma a3 comma up to an. Okay, compulsory each vector can compulsory satisfies the criteria function. Okay, so for example, so this can be explained with the four queens problem. Okay, so the desired solution for four queens problem can be taken as 4 tuple. Okay, that 4 tuples are, so queen 1 comma queen 2 comma queen 3 comma queen 4. Okay, 4 queens can be placed on 4 by 4 chessboard. So the desired solution for 4 queens problem is 2 4 1 3. Okay, so this is the desired solution for the 4 queens problem. So this can be represented as 4 tuple. Okay, each queen that is q1 comma q2 comma q3 comma q4. So each queen can be chosen from the finite set. So set of 1 comma 2 comma 3 comma 4. Okay, so these are the column numbers. Okay, queen 1 can be placed on first column or second column or third column or fourth column. Queen 2 can be placed on first column or second column or third column or fourth column. In the same way, third queen can be placed on either first column or second column or third column or fourth column. Fourth queen can be placed on either first column or second column or third column or fourth column. Okay, each qi can be chosen from the finite set, so S suffix I. So each qi is called as a solution vector. Okay, it satisfies the bounding function or criteria function. So p suffix I of, so q1 comma q2 comma q3 comma q4. Here, what is the criteria function? Okay, so the no two queens are on the same column, no two queens are on the same row, no two queens are on the same diagonal. Okay, so these are the criteria function. Each and every queen can be followed. Okay, so these are the basics for going to the backtracking recursive algorithm for backtracking. Okay, so algorithm backtrack of k. Here k is nothing but, so we are taking 4 queens. Okay, so 4 queens, each queen can be represented as k. Okay, so k contains queen 1, k contains queen 2, k contains queen 3, k contains queen 4. So k is equal to 1. We have to place queen 1 on 4 by 4 chessboard. K is equal to 2. Queen 2 can be placed on 4 by 4 chessboard. K equal to 3. Queen 3 can be placed on 4 by 4 chessboard. K equal to 4. Queen 4 can be placed on 4 by 4 chessboard. Okay, algorithm backtrack of k. Now k value can be taken as 1. Okay, for each a of k. So here the solution vector can be represented as a1, a2, a3, an. So a of k, here k value is equal to 1. So first queen we have to place. So a of 1 belongs to T of a1, a2, a3 up to a of k minus 1. Here the function t is the set of all possible values for a of 1. A of 1 can be chosen. Okay, suppose in the 4 by 4 chessboard, 4 by 4 chessboard, so a of k, k is equal to 1. That means queen 1 can be placed. Okay, what are the possible values for queen 1 can be placed as the first component? Here queen 1 can be placed on first row. Okay, so queen 1 can be placed on first column, queen 1 can be placed on second column, queen 1 can be placed on third column, queen 1 can be placed on fourth column. Okay, what are the possible values for placing queen 1 on the 4 by 4 chessboard? Okay, so first column may be placed, second column may be placed, or third column may be placed, or fourth column may be placed. So these are the possible values for placing queen 1 as the first component. Okay, so the function t contains the set of all possible values for placing queen 1 on the 4 by 4 chessboard. Okay, once the value can be chosen from the t function if it satisfies the bounding function. Here bounding function is nothing but criteria function. Suppose queen 1 can be placed on the first column. Okay, no two queens are on the same row. So there are no queens on the same row. No two queens are on the same column. So in that column only q1 is placed. In that row only q1 is placed. No two queens are on the same diagonal. In the diagonal there is no queen is there. So it satisfies the bounding function. Okay, then if a of 1 up to a of k, here we are taking only a of 1. A of 1 is a path to an answer node. Okay, yes, it is some answer node. Okay, from the root node to an answer node. Okay, here we have to place, so queen 1 can be placed at a root node. Okay, so if a of 1 is a path to an answer node, then write a of 1 to k. Okay, write a of 1 to 1, because one queen can be placed on the first column. One queen can be placed on the first column. It satisfies the bounding function or criteria function. Okay. Yes. Next, if k less than n. K less than n means n value is equal to 4. We have to place 4 twins. Now k value is 1. 1 less than 4. So yes, and if 1 less than 4 condition true, then backtrack of k plus 1. K is equal to initially 1. Now k is equal to 1 plus 1, that is equal to 2. Okay. Now backtrack of 2. Okay. So backtrack of k value is equal to 2. Next one. For each a of k, now k value is equal to 2. That is a of 2. We have to place second queen. Okay. What are the possible values for placing queen 2? Okay. Here queen 2 can be placed on in this column. Queen 2 can be placed on second row. Okay. Queen 2 can be placed on this column or this column or this column or this column. Okay. Queen 2 can be placed on either first column or second column or third column or fourth column. Okay. What are the possible values for placing queen 2? First column, second column, third column, fourth column. Okay. If bounding function, whatever the column number we have to chosen, it satisfies the bounding function. Okay. So queen 2 can be placed on this column? No, because queen 1 and queen 2 are on the same column. So this position is not possible for placing queen 2. So this position can be chosen? No. Queen 2 and queen 1 are placed on the same diagonal. So it is not possible. So this position we have to choose it? Yes. Queen 2 can be placed on this column. No two queens are on the same row. Yes. No two queens are on the same column. Yes. No two queens are on the same diagonal. Yes. So here bounding function is true for placing queen 2 on third column. Yes. If a of 1, a of 2, a of k is a path to an answer node. So now this is the root node. Now we have to place second queen. So second queen can be placed on third column. Okay. So root node to answer node. Here we have a1 comma a2 is a path to an answer node. So this is the path from root node to this node. Okay. So then write a of 1 to k. So a of 1 to 2. So 1 is nothing but root node. 2 is nothing but queen 2 can be placed on which column? Okay. If k less than n. Yes, k less than n, k value 2. 2 less than 4. Condition true. Then backtrack of k plus 1. So now k value is equal to 2 plus 1, that is equal to 3. So again algorithm backtrack of k. Here now k value is equal to 3. Okay. For each a of 3, so belongs to t function. What are the possible values for placing queen 3 in 4x4 chessboard? What are the possible values? Queen 3 can be placed on this column or this column or this column or this column. 4 possibilities are there. Okay. So by selecting which possibility, it satisfies the bounding function. Okay. So queen 3 can be placed on this column. It is not possible. Queen 3 can be placed on this column. It is not possible. Queen 3 can be placed on this column. It is not possible. Queen 3 can be placed on this column. It is not possible. So bounding function is false. Okay. If the bounding function is false, again we have to backtrack. Okay. So again we have to backtrack. So queen 2 can be placed on this column. Okay. So queen 2 can be placed on this column, suppose. So now queen 3 can be placed on this column? No. Queen 3 can be placed on this column? Yes. Queen 3 can be placed on this column. Okay. Next. Now k value is incremented. Now k value is equal to 4. After backtracking, we have to change the queen 2 position from third column to fourth column. So after changing the second queen from third column to fourth column, now check for queen 3. Queen 3 can be placed on first column. It is not possible. Queen 3 can be placed on second column. Yes, it is possible. Okay. Now placing queen 4. K is equal to 4. So for each A of K, queen 4 can be placed on either first column or second column or third column or fourth column. Okay. So queen 4 can be placed on this column. It is not possible. Queen 4 can be placed on this column. It is not possible. Queen 4 can be placed on this column. It is not possible. Queen 4 can be placed on this column. It is not possible. Okay, here the bounding function is false. Again, we have to backtrack. So after backtracking, so queen 3 can be placed on this column. It is not possible. Queen 3 can be placed on this column. It is not possible. Queen 2, there are 4 chances are completed for queen 2. Now changing the queen 1 position from the first column to second column. Okay. So now after changing the queen 1 position to second column, so queen 2 is placed on fourth column. Yes, it is possible. No two queens are on the same row. No two queens are on the same column. No two queens are on the same diagonal. Okay. Now what is the position for queen 3? Position for queen 3 is this position. Okay. Now what is the position for queen 4? Yes, queen 4 position is this one. Okay. So after backtracking, queen 1 can be positioned at second column. Queen 2 can be positioned on fourth column. Queen 3 can be positioned on first column. Queen 4 can be positioned on third column. Okay. If k less than n, 4 less than 4. 4 less than after placing 4 queens, so root node, a path to an answer node. So 4 queens are placed. We have get a path from root node to an answer node. Then write a of 1 to k. Now k value is equal to 4. A of 1 to 4. A of 1 to 4 is nothing but first queen can be placed on second column. Second queen can be placed on fourth column. Third queen can be placed on first column. And fourth queen can be placed on fourth column. Okay. Whenever 4 queens are placed, okay, the state space tree is generated for queen 1 position, that is second column, queen 2 position, fourth column, queen 3 position, first column, queen 4 position, fourth column. So after placing 4 queens, we are getting the total state space tree from root node to an answer node. So whenever all the 4 queens are placed on 4x4 chessboard, so then we have to stop the procedure. Now we are getting the answer node in the state space tree. Whenever we are getting the answer node in the state space tree, okay, we have to stop the procedure. Okay, so the solution can be written as write a of 1 to k. Here k value now 4. Write a of 1 to 4. So the solution vector a of 1 to 4 is equal to, so 2 comma 4 comma 1 comma 3. Okay. So this is the final solution for 4 queens problem. Okay. Here k is nothing but, so we are taking 4 queens problem. We have to take 4 queens. K is equal to 1 first queen. K is equal to 2 second queen. K is equal to 3 third queen. K is equal to 4 fourth queen. Now we are starting with k is equal to 1. We have to place first queen. So for each a of 1, what are the possible values for placing first queen in the state space tree or 4x4 chessboard? Okay, these possible values can be taken from capital T set. Okay, whatever the value that can be taken for queen 1, okay, it satisfies the bounding function or not. Here bounding function is no two queens are on the same row, no two queens are on the same column, no two queens are on the same diagonal. If the bounding function is satisfied, okay, we are already placing the first queen on the 4x4 chessboard. Okay, so we are getting the path from root node to the first node. First node is nothing but we have to place the first queen on which column. Okay, then write A of 1 to 1. A of 1 to 1 is nothing but we have to place the first queen. Okay, so this procedure is write A of 1 to 1. If k less than n, k value 1, n value is 4. 4 queens we have to place. 1 less than 4, then backtrack of k plus 1. Now go to k value 2. Okay, what are the possible values for queen 2? Okay, once we are getting the possible value for queen 2, if it satisfies the bounding function or not. If it satisfies the bounding function, we have to draw the state space tree from root node to the second queen column number. Okay, once we are getting, write A of 1 to 2. Okay, if k less than n, 2 less than 4, condition true, backtrack of k plus 1. Now k value 3. A of 3, what are the possible values for queen 3? Okay, if we are choosing the value from the queen 3, if it satisfies the bounding function. If it is not satisfies the bounding function, again we have to backtrack. Okay, if it satisfies the bounding function, so then we have to draw the state space tree from root node to this answer node. Okay, so this procedure is repeated until all 4 queens can be placed on 4x4 chessboard. Once we are getting the 4 queens column numbers, okay, we have to get the total state space tree from root node to the answer node. Then we have to draw the A of 1 to 4, k value 4. So 1 to 4 is nothing but queen 1 can be placed on second column, queen 2 can be placed on fourth column, queen 3 can be placed on first column, queen 4 can be placed on third column. Now we have to draw the entire state space tree. This is the solution for 4 queens problem. So thank you for watching this video. If you like this video, please subscribe my channel name. So Dibbela Srinivasarao. If you like this video, please share this video to your friends and classmates. Thank you.